My timer ran up. I limit myself to 9 minutes so that way I'm not rambling on for 45 minutes. So, sorry, that's what happened. But as we were saying, we have a negative velocity. We already determined that was d, if I remember correctly, all 3 minutes ago. And the acceleration versus time graph, we're moving away closer to negatives, and then there's 0 acceleration, and then we're moving more towards positive velocities. So it's going to start out as a negative acceleration, 0 acceleration, and then a positive acceleration. Now for this test your understanding, 4 objects move in a 4-second interval, and we are ranking in terms of acceleration and displacement during this time. So what I'm going to do is I'm going to first figure out what is the acceleration and displacement, and then I'll rank them. Delta x and delta x. D, C, B, and A. Alright, so how do we get displacement from velocity? I don't know. Let's check that. The rules at the beginning of this test your understanding. So first thing I'm looking at is this is acceleration and displacement. Displacement, not distance. So direction matters. So that means when we find the area under the curve for the displacement, we have a negative area and we have a positive area. So this area is going to be 1 times negative 10. So it's negative 10. And then this area is going to be 1 times positive 10, 10. My displacement is 0. My displacement here is 10 times 4 because it's all positive. So it's 4 meters. Always have your units, Mr. Scapetas. My displacement for object C, we have, if you can look at this and see that those two are going to cancel each other out, that's great. If not, it's 1 times 5, so it's positive 5, and then 1 times negative 5 is negative 5. Add those together, and you get another 0. And then for object D, it is going to be 2 times negative 10, so negative 20 meters. There's our displacement. Let's go ahead and, we can rank those. Sure, which one has the most forward displacement? It's going to be B. And then we have, is 0 bigger than negative 20? Oh yes. So we have A equals, so B is greater than A, while A equals C, which is greater than D. That's the notation you should use for that. Now for the acceleration, how are we going to get acceleration from a velocity versus time graph? We're going to take the slope. Our slope of this first line, rise over run. So we're going up 10 over 2, or we're going up 20 over 4. Either way, we're going to get A equals 4. So let's do A equals A, B, AC, AD. A is positive 4. That's an equal sign, not a negative. 4 meters per second squared. B, what is the slope here? 0. Oh boy, I don't want to erase that. Sorry. Alright, so for C, what's happening with C? We are dropping down 510, so we're going to have a negative acceleration. Our velocity is getting closer to negative. Dropping down 10 divided by 4 is 2.5. So we have 2.5 meters per second squared. And then for D, our slope here is positive. Going up 10 over 4 is, that's a negative, this is a positive 2.5 meters per second squared. Negative. Alright, so let's go through and rank these. The most forward acceleration is going to be A, which is greater than D, as our next positive acceleration, is greater than 0, which is B, and that is greater than C. So that's it for that one.